Hey everybody, this video is going to talk you through the introduction to multiplying polynomials. Now, if you don't have a printer at home and you weren't able to print this off, you can just use a separate piece of paper and just jot down the notes. Or if you've got a touchscreen Chromebook, you can turn these notes into a PDF and be able to kind of follow along and write on your screen, kind of like I'm going to do in the video. Whatever works for you guys, whatever is easiest, okay? It does not matter to me. So here we need to talk about distributing first. So you'll notice our learning target says I can multiply a monomial and a polynomial by distributing. So hopefully you remember monomial means there's only one term and polynomial means many terms. So when we think about distributing, we have to remember that we're multiplying the outside term to all the terms on the inside. So if we look at that first example there, there's this 3 on the outside, and we're going to multiply it inside. So we get 3x squared minus 12x plus 21. It's nice and easy. All we do is multiply the numbers and move on with our lives, and we're good to go. So there's some good news here for you guys. What this means then is that if we're multiplying a monomial, sorry, I got the wrong colors here. If we're multiplying a monomial and any other polynomial, we just have to distribute. So just as another quick reminder, monomial means that it's only one term. So if we have one term sitting in front of a polynomial, all we have to do is distribute it inside. So if you're multiplying two terms, there's something you have to remember. You're going to multiply the coefficients, so the numbers in front of the variables, and that's exactly what we did in this example up at the top, right? We took that 3 and brought it inside by multiplying the numbers, right? That's all we did. That's no different. Now, the new part here is that we started then talking about um, monomials that aren't just constants, they have variables as well. And so you might have multiple variables, which means you're then going to have to add the exponents. And this is something that we did in chapter 8. Think back to when we did stuff like x to the fifth times x to the fourth power, right? If you're multiplying two things of the same base, you add the exponents. So this is going to be x to the ninth. All right, so let's take a look at what this really looks like in an example here. So we're going to be taking this monomial that's in front, this 2x to the third, and we're going to distribute it inside. All right, so we're going to kind of do this one step at a time. So it's 2x to the third times x cubed. So what I'm going to do is I'm actually going to take this 2x to the third and I'm going to multiply it by x to the third power. And then I'm going to do 2x to the third again, and I'm going to multiply it by 3x squared. And then I'm going to take that 2x to the third and I'm going to multiply it by negative 2x. And then finally, I'm going to take that 2x to the third and multiply it by 5. Now I know I'm taking up a lot of space here to be able to write that, but I kind of want you guys to understand where this is all coming from. So you'll notice that 2x to the third is the monomial that was in front, and it's repeated 4 times here. And the reason for that is because our polynomial that's inside the parentheses, that's what I'm highlighting in green right now, that's all right there. All I did was take what was inside the parentheses and kind of space it out, and I put the 2x to the third with each of them. Now I'm just going to go ahead and follow my rule up here. If you're multiplying terms, you multiply the coefficients and you add the exponents. So let's see, the first one we've got a coefficient, there's an invisible 1 on this one, right? So 2 times 1 is going to be 2. Add the exponents, and we get 3 plus 3 is 6. Multiply the coefficients, so we'd have 6 as our coefficient. Add the exponents, and we'd get 5. Now, when we multiply these two coefficients, that's going to become a -4. And add the exponents, we have to remember then that there's an invisible 1 there. So that's going to be an exponent of 4. And then we've got 2x to the third times 5. That's just going to be 10x to the third. And there's our final answer. This is probably stuff that you guys have done before. This probably does not seem that hard. I'm just trying to show you the work so that you understand where it's coming from, just in case you forget. So now we're going to do one more example. So 3x squared, we're going to do times 2x to the third. So multiply the coefficients, add the exponents. 3 times 2 is 6. But then when we add the exponents, we're going to get 5. Then we're going to do 3x squared times -x squared. And that's going to become -3x to the fourth. 3x squared times 4x is going to give us a positive 12x to the third. And then 3x squared times -3 is going to give us -9x squared. And there's our final answer. Now you'll notice that the original polynomials I gave you were already in standard form and they were already simplified as fully as they could be. So we didn't have to worry about doing that, right? If we look at both of these examples, the answers are written in standard form and there's no like terms for us to take care of. But that's something you always kind of want to check for when you're multiplying polynomials. All right, if you have any questions, please reach out to me right away so that we can get this taken care of before we move on to the next section later on this week. Actually, you guys are going to do some practice later this week, and then we'll move on to the next section next week. All right, I hope you guys are doing well. Again, reach out to me if you need anything, and I miss you guys.